I created an MCP server that can automatically generate Adobe Premiere Pro plugins, and I wanted to show it to you guys today. If we take a look at my screen here, I've got what is possibly the world's worst game ever of Tic Tac Toe, but what makes it special is that it actually exists as a panel inside Adobe Premiere Pro. Now, for those of you that don't create videos, Adobe Premiere Pro is an application that you use to edit videos, and it allows you to create plugins. This is kind of like creating plugins in VS Code or JetBrains, but the main difference is it's absolutely terrible to develop. And what we're looking at is AI's output for a Tic Tac Toe game inside of Adobe Premiere Pro. Let's give it a shot. Let's play it. I know it looks a little funky. Everything's on one line, but it's AI. Not everything's going to be perfect. All right, let's go. X. Put an O over here, I guess. That's looking good. Another X. Let's put an O here. I'm going to have X win. X is going to win today. X, O, X. I guess not. Player X wins. Okay. So not the world's best game of tic-tac-toe, but you get the idea. Now, I said I built this using an Adobe Premiere Pro plugin generator MCP server, but I didn't use Claude Desktop. I built my own MCP client, and this time it's got a UI, and that's what we're going to talk about next. So we take a look at my screen again. We're looking at the MCP client desktop app that I built. And this is basically a clone of Claude Desktop. The only difference is I can select whatever model I want, and I can install whatever MCP servers I want, and I can have them running locally in the cloud. I can do whatever I want. I'm the owner of this application. And if we look at the conversation, we should be pretty familiar with AI conversations at this point. I'm on the right-hand side here, and I said, make me an Adobe plugin called Tommy Codes Test, and it's going to allow the user to play tic-tac-toe. Now, don't worry if you have no idea how Premiere Pro works, how to create plugins. That's not really going to be necessary for this video, but let's follow along in the conversation and see exactly what it did. I want to walk through all of the different tools I implemented, why they exist, and talk about basically how this works at a deep level. I think that's going to be really interesting. So we look over here. The first thing that happens is the assistant is going to call a tool called init plugin. And the plugin name, it seems like it was able to parse out from my message, so that's good. And it looks like it's telling us that the plugin was created in a directory here on my Mac, which makes sense. Then we're going to go ahead and get the documentation. And I'll explain why we need this later, but if we take a look at the output of Git documentation, we'll notice that we have what kind of looks like a markdown document. It's plain English. It's telling the AI exactly how I want this plugin implemented. It's giving it implementation details, lower level stuff on how the framework works in the first place. And we can scroll down here. We're going to see code snippets. We're going to see what looks like documentation ripped straight from Adobe website, that kind of stuff here. Also take note that the different tool calls in this application have different UI panels. Then the assistant is going to go and tree the source code. So if you ever run the Unix tree command in your terminal, you're probably familiar with this output. Why don't I show you guys in my terminal what that looks like? We're going to do tree. And I have a lot of files here because of node modules, but that's the output of tree. It just shows you what all of your files are in the directories and their subdirectories. After the assistant does that, it's going to go in and read some of the files. So we're taking a look here. It's reading through source main.tsx and then index react.tsx. If we go up in the source tree, we'll notice that under source, there is a file called main.tsx, and there is also a file called index react.tsx. So the AI assistant first went out and treed the source code so it sees what files are available, and then it's going to go in and read the contents of a select few of those files. Then it's going to call a tool called write files. So this is the assistant making changes to the source code. Up until this point, it was just reading through things, and it ran the initialization step. Then it's going to go and try to build the plugin. So it's going to run an npm run build. It's going to compile the JavaScript down into the minified version that's required for Adobe Premiere Pro. And it got an error. There was some property that didn't exist. So TypeScript, the TypeScript compiler, is running as part of this build step as well. Then we look down here, and it's going to rewrite the contents of source/main.tsx. Then it's going to rerun the build tool. And finally, the build succeeded, and it's telling me, you can go ahead and play tic-tac-toe, enjoy. So I know that's a lot of different tool calls. We're going to break them all down for you, and I'm going to explain why they work the way that they do, and why you don't actually need that many tools to implement a lot of functionality if you're careful about what arguments you provide in the tool calls. So let's go ahead and check out the source code for the Adobe server. Oh, and by the way, if you guys are interested in how the front end for this app works, let me know in the comments because I'm happy to make a video on that. But this video is really going to be focused on the back end and the server component, specifically the Adobe Premiere Pro plugin server. So now we're back in WebStorm, and what we're taking a look at here is the source code for the Adobe Premiere Pro plugin maker MCP server that I implemented. For some context, I'm running this as an in-memory MCP server. I didn't really want to run it as a sub-process, and I definitely didn't want to host this in the cloud because I need to build and test the plugins locally. I really want to be able to modify my own file system. I think that makes the servers a lot more powerful, and for that reason, you cannot have them running in a cloud. You need them running locally. But the init plugin tool is going to get the skeleton of the project set up. And if we recall back when we were looking at the conversation, when the AI assistant called source code tree, so it was asking me to output the contents of the source code tree, we already had a full project. Or not necessarily a full project, but we already had a project skeleton. The init plugin is going to go and create that skeleton. So if we take a look at the implementation of the init plugin, what's happening is in my file tree, I have a template plugin. It's called Adobe_plugin. And it's got the main skeleton that's going to be used for any Adobe plugin. And more or less what this tool is doing is it's running an rsync from Adobe plugin. So it's copying all of the code here, and it's going into a plugins directory that I configured, and it's creating a subdirectory that I specified, in this case, Tommy Codes Tests, and it's going to go and copy all of the files from Adobe plugin, and it's going to copy them into the Tommy Codes Tests plugin. And that's going to get everything started. You don't necessarily want to have the AI output all of the file structure from scratch. If you can hold its hand a little bit, especially in some of the more important steps, it's going to help it be successful going forward. That's going to give it a huge advantage. Back to the conversation, the first thing it did after initting the plugin was call for the documentation. Let's take a look at the tool description for Get Documentation. And as we can see, it's just going to return a markdown document that the AI assistant can use to better understand the Adobe plugin framework. Part of the reason this is so important for this particular MCP server is creating Adobe Premiere Pro plugins is a little bit like black magic, and nobody understands how it works. There's not hundreds of thousands of Stack Overflow questions going into exquisite detail for all the different edge cases. There's really some poorly written documentation. And to make matters worse, there's a new way to do Adobe plugins that's brand new that literally came out in December of 2024. And these language models, their training cutoffs were well before then. And if you want to have them one-shot Adobe plugins, you need to give them a very detailed list of notes. And that's what we're doing here. And you'll notice that I'm actually telling it in all caps, you must call this code because it contains very important information about how to write the code. I don't want it going off and trying to one-shot a plugin without having this documentation because it's almost 1,000% of the time going to hallucinate because no way it knows that stuff. There's just no way it knows how to create an Adobe plugin, at least with the new framework. And for that reason, we have a markdown document. It's actually in a file called notes.md, and we're really not going to go through all of this. It's kind of gigantic. It's 750 lines. Half of this is basically documentation I stripped directly from the Adobe developer docs. And the other half, I wrote some of myself. So I went in and implemented some of the trickier pieces, and I figured out how you actually do that kind of stuff in the Adobe API. And then I wrote notes telling the AI, hey, if somebody asks you, for instance, so moving items into bins, so that would be organizing your files within Adobe Premiere Pro, was not very obvious from the API. And for that reason, I wrote up a guide on how to do it successfully. And so this part of the document here, I wrote myself. But anyway, the reason I'm making the AI assistant read the documentation before it can write any code is that it needs to know all this stuff. So, and because of the description of the tool, it's really afraid to not call this tool first because I'm telling it in all caps, you must call this tool. Anyway, then we're going to call source code tree. So here's the tree source code tool description. And I realized we forgot to look at some of the arguments for these tools. It's not that relevant for Get documentation. There are no arguments. But for tree source code, the only argument is a plugin name. And that's because within a single conversation in this application I built, you're able to have the AI work on multiple different plugins. And you would specify the name of the plugin somewhere in your prompt so that it knows where to look. But regardless, it's going to tree the source code of the plugin that you provide in the name. And usually you would only have one in a conversation. I wouldn't recommend having it do multiple different plugins within a single conversation. But regardless, this is going to go in, and the implementation is really not that interesting. It's doing some Node.js stuff to do a tree of the file contents. And I have a little secret for you guys. I had the AI write that for me. That's a really good place to actually go in and do some vibe coding because the inputs and outputs of this tool are very straightforward. And it's very easy to describe in English what you want. And it's very easy to grade the vibe coded results. So I didn't really want to deal with figuring out how to do this in Node.js. So this is indeed something I vibe coded. We are finally on to something a little more interesting. This one is called read file contents. The AI assistant is going to give us a list of file paths, and we're going to return to it the contents of those files in a JSON object. And this is so the AI assistant knows what it's working with, what it's starting with. It knows what modifications it needs to make. Because up until this point, it knows what the source code tree looks like. It knows what the documentation is. It knows what it wants to do. But before it can actually go in and implement anything, it needs to know where we're starting. It's smart enough to go in and read the contents of 2 of the files that it thinks it might need to modify. And source main.tsx is one of the entry points for the plugin. Again, it does not matter for this video if you know why this file is important. Just know that this would be one of the entry points, and the AI was able to figure out this is where it needs to start. It's going to go ahead and read those files, and then you're going to notice that it's going to call a tool called write file contents. Write file contents, it's similar to read file contents, but now instead of the AI only providing the names of the files that it wants to write, it also has to provide the full contents of the file. So this is how the AI can go in and modify things in your source code for you. It tells you what files it wants to modify and what the body of those files needs to be. The way I implemented it is the AI is just going to go in and completely overwrite whatever was in the file. This is a little inefficient in terms of tokens because it has to go and output the entire contents of the file. You run the risk of it making a mistake and hallucinating a part of the file or just randomly dropping a part of the file. But implementing something that uses diffing or some kind of change set is a lot more complicated, and I didn't want to do it just for this application. Okay, so we have read file contents. Let's take a look at the schema. And you'll notice that it's a plugin name. So again, all of these arguments are going to require a plugin name, and then it's a list of file paths. And the response schema is going to be a map containing string keys for the file names and string values for the file contents. And optionally an error message in case something goes wrong. And write files is going to contain an array of file path content tuples. And this would be the assistant telling us, hey, replace source/main.tsx with this gigantic dump that I got for you. And let's take a look at the descriptions. This one is kind of interesting, write file contents, particularly this last line. Always call this tool instead of outputting code directly to the user unless they explicitly ask you to do that. This is one of those weird things where you're developing an agent, when you're developing an AI application and you really need to deal with the prompt engineering, and this is really annoying stuff. But basically, when I was testing this out, sometimes it would just dump the file contents to the user in the assistant message and not call this tool, which is not useful at all. And maybe there's a way to around this without having to just tell it explicitly, but I figured, okay, let me just put it in the tool description and say, hey, you better use this tool instead of dumping the user the file contents directly, because they don't want to see that. They don't care. Notice how these descriptions are pretty short. This is not a gigantic essay about how the tool works. It's relatively straightforward. And the arguments to both read file contents and write file contents are very flexible. This enables a lot of different stuff. The AI assistant can really build any type of application with just these primitives. And that's what I like about the approach that I built here, is that I wanted to make the tools flexible enough in their arguments so that I didn't have to implement like 50 of them and have weird edge cases. I'm pushing a lot of the flexibility onto the AI assistant and allowing it to get creative in its arguments, which in our case would be the file contents. Anyway, now that it's written the files, it's going to go in and build the plugin. If you ever work with a JavaScript project, you have to build the code, which is very unfortunate because it's not compiling it in the same sense that you would compile C++ code into bytecode. It's taking your source JavaScript, usually TypeScript, and turning it into a disgusting one-line mess of all your JavaScript code. And that's going to happen with npm run build. And if we look at this tool's implementation, well, first of all, the first time it called this tool, it made a mistake. It got some TypeScript compile error. Okay, so here's the description of build plugin. As we can see here, I'm telling the assistant, hey, when you call build plugin, it's just going to go ahead and run npm run build, and it's going to return to you the result of that build. Let's check out the schema. Again, just the plugin name, no extra arguments. And we're going to look at the response. The response is going to be of type build plugin response. And it's going to return the exit code, which hopefully is 0, which means there weren't any errors. Or it's going to return an error message, which is going to tell the AI assistant what went wrong, which in our case did happen. The implementation is a little ugly. I vibe coded this as well. But more or less what's happening is we're running npm run build in a sub-process using the sub-process modules in Node.js. And we're returning the exit code to the user. It gets a little complicated because this is an Electron app, and if you want to deploy this to production, you need to make sure that the user whose laptop you're running on has npm installed. And so part of the nastiness in this tool is going in and ensuring that the user has npm installed on their system and available on their path. So we're not going to really go into too much detail, but just know that it's basically running an npm run build, and I'm piping the output back. It did generate an error here, and in my UI, I'm displaying that in red, so it's very obvious. But the assistant as well was able to detect that an error happened. And so without me needing to even tell it anything, it went ahead and called write file contents again, but this time with new file contents. And if you look, it actually provided not just a tool call, but an assistant message to notify us that this was going on. It's telling us, hey, the build failed. It seemed like there was some error related to this like UXP thing. I'm going to go ahead and try again to write that file. Then it does that. And then it also knows to call build plugin. And then only once it's done building the plugin does it give us the message and the tool calling loop stops. And we're able to go in and install the plugin and run it for you guys. So that's how this works at a very high level. That's what the tools do. I think some things I want to call out. First of all, this is model agnostic. I'm actually running DeepSeek Chat in this one, which would be the DeepSeek V3 as of recording this video, mainly because it's cheap and it's smart enough to get the job done. You could run this with GPT-4o. It's decent enough. Claude is definitely the best. GPT-4o Mini is just too stupid. It can't figure this stuff out. It gets into these weird loops, and especially when the context window is this long, it starts to get a little funky. These two tools here, write file contents and read file contents, give the AI assistant here the majority of its flexibility. And the fact that these tools are so powerful are what enables me to not need to write 50 million tools like I was talking about earlier. It can write any file it wants. It can create a new file on the file system. It can rename a file. It can read files. It really can output whatever it wants. I mean, if it wanted to, it could output a Python app. It wouldn't be able to build it because I'm not exposing a just open shell tool, but that's something that you could do. I chose for this implementation to have a build tool specifically and say the only thing you're allowed to call is npm run build, and I'm going to be babysitting you while you do that. But one thing that you could do if you wanted a lot more flexibility is create a tool called run anything in the shell and just give it full access to a shell-like environment, and it would be able to do pretty much anything on your system. The downsides of that are pretty obvious security. I mean, if you're allowing it to write code on your shell and do whatever it wants, it can really mess up your computer, which is not something that people want, obviously. But the closer your tools are to just write and run any code you want, it's kind of becomes true that you don't need as many tools, but also you start to run into security risks and also efficiency risks. If there are ways to write tools that don't require it outputting gigantic file contents, but that can still satisfy the needs of your users in your application, maybe that would make more sense. And what I want to talk about now is managing the conversation and some of the issues with this approach. Now, chat apps are pretty much synonymous with AI now, and almost every single AI application is going to have some kind of chat component to it. But one of the problems, especially in an application like this, where it's reading and writing large strings, is the context window is already getting very, very big. So I copied the notes.md, and we're going to paste them into the OpenAI tokenizer. And this alone is 5,600 tokens, which on its own is not insane. Like, this is, these language models can handle a lot more than 5,600. But already, like 3 tool calls into this conversation, we have already used over 5,600 tokens, and we're probably going to be using more, as you could guess. And every message that gets sent, every tool that gets called, we're starting to eat up more and more of the context window. And as we get to the bottom of this conversation, I don't have the exact numbers, but I wouldn't be surprised if this was over 30,000 tokens. And DeepSeek in particular only has a 64,000 token context window. GPT and Claude have like 128,000 and 200,000 respectively. I know that some of the newer, like Gemini has 2 million. Llama 4, which came out yesterday, has a bajillion. But even with these models that have larger context windows, you don't want to be using all of these tokens. 1, it's expensive. 2, it's slow. And 3, regardless of the advertised context window limit on the model, every single model is going to start to get amnesia as you use more and more tokens. So even if they technically let you use 1 million, I would not expect the model to be as intelligent with 900,000 tokens as it would be with 900 tokens. But at this point, so if I want to make any modifications to this, so let's make the grid even bigger. So instead of it being a 3x3 grid, let's make it a 4x4 grid. Now, so let's try this. Now, can you make it a 4x4 grid? And the assistant's going to be thinking, and this is good for you guys to see live of what it looks like. But at this point, this message is going to include the entire conversation in its context. And what that means is it's going to be a lot slower because it has to process every single one of those tokens. I'm going to be paying more for these tokens because there's just more of them. And it's more likely to get confused because, to be honest, like a lot of this stuff at the beginning isn't maybe relevant. Like it already read the contents of one of the files. And yeah, actually, that's a good point. So it read the contents of the file main.tsx multiple times. First, it read the initial contents, then it wrote the contents of main.tsx, and then it rewrote the contents of main.tsx. So it has in its context window 3 distinct versions of the main.tsx file. And I'm sure it'll figure it out. Oh, wow. Okay, so and this is an example where I need to modify my descriptions, because what happened is, exactly. So this is exactly what I was talking about earlier, where it just dumped the code on me instead of actually calling the right file contents tool. And so this is bad DeepSeek. This is 20 lashings for DeepSeek at the very least. But this isn't that surprising that it's happening now, because we are much later in the context window of this conversation. And so the chances that it's going to remember the tool descriptions. The tool descriptions, by the way, are at the very top. The tool descriptions are pasted into the system prompt, which are at the very top of the conversation. And so honestly, at this point, it probably just forgot about the tool descriptions, and that all caps where I told it, you must call the right file contents tool or I'm going to be very mad, whatever, or you're going to get fired, whatever people type in. It just forgot about that by this point. So what you really need to do now is create a new conversation, which is really not a good user experience. If you have an application like this, right now, I'm just managing these conversations as arrays of messages. So the entire conversation is just an array of these chat messages, and I only ever append to the messages array. And that makes it easy for me as the developer, and it makes it easy to have this chat-like app. But really what I need to be doing on the back end is managing the context manually. Like I mentioned earlier, source main.tsx appears in the context window 3 times. I need to be managing that on the back end, and I need to be removing the 2 no longer useful versions of main.tsx. And the other thing is source tree. Like if it were to add a file, I'd probably want to just have the up-to-date version of this instead of the entire history. But now we're getting further away from a chat app. And the reason I bring this stuff up is I think a lot of the appeal of MCP is that we're going to have this USB-C for AI, and you're going to be able to plug in any kind of server into any kind of application. Like maybe Claude Desktop becomes this all-knowing God-like app that can connect to whatever you want and works for anything. Right now, it's definitely not there, and the main issues are with the UI and the configuration, but desktop clone for you guys. And the UI of just a conversation is not good enough for this type of application, and it matters how the client is implemented. It matters how the UI is displayed for the particular application. It matters that this is a Adobe server in particular and not the file system server or the HubSpot server or the GitHub server, whatever. Like the UI and the experience of using this MCP server is inherently different. And I think that's a problem that we're still going to have to solve, is how can we maybe package up UI and control of messages into the MCP servers themselves? And how can the clients become more extensible to allow different types of UI components to be plug and played? I think that's going to become very important. What I hope you guys learned from this video is that flexible tool descriptions are very powerful in MCP servers, and they allow the assistant to get very intelligent with not a lot of work on your part. If you guys want to learn more about how MCP tools are called and how they work in the first place, check out this video up here.